Okay, we're going to do example number 6 here. A 3 kilogram block, the box here is 3 kilograms, M1, and a 6 kilogram box is M2, and it's being pulled by a 133.2 Newton pull force, and that pull force is upward. It's asking us to draw both free body diagrams and find the acceleration of the blocks and both tension forces. Okay. So we'll start off by drawing our free body diagrams. We'll call this one free body diagram of M1. And M1 is 3 kilograms. Okay, and there we'll do the other one as well. We'll label the top right now, free body diagram of M2. And that is 6 kilograms. We don't know which way it's moving up. We have to do some calculations here, but we can draw a free body diagram, draw both objects. Let's do M2 first, it's easier. There's a force of gravity pulling down on it. And there's a tension force, T2, pulling up. T2 is pulling up on M2, but it's actually pulling down on M1. So T2 is pulling down on M1, and T1 is pulling up on M1. And the pull force and T1 here are equal. Because the pulling up on there, it's going to be just transferred through that rope. So these are equal forces. Pull force and T1 are equal. There's one other force that I'm missing there, the force of gravity pulling down on M1. There's always a force of gravity pulling down, but also T2 is pulling down on it. This block M2 is pulling down on M1. Okay? Now, before I do any more system work here, which I'm anticipating because this is our 6th example here, I'm going to figure out what the force of gravity is on both of these, because I will need those forces, and it's an easy one. The force of gravity here is just mg on that block, so the force of gravity is 3 kilograms times the gravitational field strength. We're going to assume that it's here on the Earth, 9.8 newtons per kilogram. Okay, so the force of gravity here is going to be, what's 3 times 9.8? 29.4. We'll do the force of gravity on this guy too, just in case, and we will need it. That is a 6 kilogram block, 9.8 newtons per kilogram. So the force of gravity there is going to be 58.8. We'll need that. Those are the weights, the forces of gravity of both of those objects. So let's deal with the system now. What's the mass of the system? 9 kilograms. Okay. And what is the sum of the forces on the system? Well, the sum of the forces on the system, again, we have to take a look at the direction of motion. I don't know what the direction of motion is. I know it's up or down. But what is it? Okay, well, it's in this direction on both of them. It's either up or down, up or down. So we have to include all the forces, but we don't include the tension forces. Okay, at least tension 2, because that's between the two objects. It's like pull force each direction, and they cancel out. Okay, so which direction is winning? Well, let's just add up all the forces and find out, see if we can. So the sum of the forces, there's 133 Newton force pulling up, 133.2. That's the pull force going up. Okay, I'm just going to erase that. I'd rather do it with the terms first and then plug in the numbers. Okay, so I'll just write down pull here. Minus the force of gravity of number 1 minus the force of gravity of number 2. They're opposite directions. I'll write out the number, and if it's negative, then the gravity's winning. Here I've done it as the pull force minus the gravity. So that's 133.2 newtons minus the force of gravity of number 1, which is 29.4, minus the 58.8, and those are both newtons as well. So this is going to be 45 newtons. And that is, the direction of that one is up. I can put it there, or I could have written down up. It's important that I label the direction there because we didn't know it. I just anticipated that 133 newtons would be larger than 29.4 and 58. But if it was negative, then I chose the wrong direction here. I put pull minus force of gravity minus force of gravity. It would have been the other way around. So if it was wrong, if it was a larger mass here, it would have been definitely going down. Okay, so I now write out Newton's second law. The sum of the forces is equal to F net equals ma. Definitely do that and write it down. That's an important law. And now we'll start plugging it in. The sum of the forces, 45 newtons, is equal to the mass, 9 kilograms, times A. The acceleration is 5 meters per second squared up. Got my answer. Let's box it off. Okay. Looking good. Now let's deal with M1. Okay, so I'm going to deal with M1 over here. Try to do it without scrolling on the page so we can see all the answers. We'll write down Newton's second law. Sum of the forces is equal to F net, which equals ma. Okay. Oh, goodness gracious, M1. I took the hardest one first. We have to look in this direction, but up. I'm going to erase that yellow in just a second, but we have to take the winning force, subtract the two losing forces. So it's going to be T1 minus T2 minus the force of gravity. T1 minus T2 minus the force of gravity. So I'll get rid of the yellows. So it's T1 minus T2 minus the force of gravity, and that has to equal ma of that object. Not of the system, of this object. That's what we're dealing with, is M1. So T1, which is the pull force, is 133.2. Minus T2, that's our unknown. Minus the force of gravity of this object, which is 29.4. And that has to equal mass, 3 kilograms, times an acceleration of 5. Okay, so that gives us T2 is equal to 133.2 minus 29.4 minus the 15. Where does the 15 come from? That was the 3 times the 5 here. So what do I get? I get that T T2 is equal to 133.2 minus 29.4 minus 15. Pull out your calculators. What does it equal? 88.8. Thank you. Thank you, person A. And let's box that off. That's our answer. It's an important one because that's the only other answer. If this was, as I said before, a multiple choice question, go on. Unless you need to do your checks, and sometimes you might want to do it even then if it's multiple choice. Make sure you're doing it right because that's a lot of work. Let's do our check. Okay? Yes?
For the check, I keep doing like acceleration and just seeing if like what I come up with equals the mass of, like, would you take that? Like I did
Well,
F net equals MA and then I did 88.8 minus 58.8 equals MA.
well, the 88.8, so you're with the check, I always suggest, you don't have to, but I always suggest the last tension you just calculate, pretend you don't know it and try to calculate again. So don't use the 88.8. See if you can calculate the 88.8 again. Okay? I'll take a look at your answer in a second if you want. Okay, so let's switch colors to red here, and we'll deal with M2. I'll deal with M2 right here. And this is a check, and what I'm going to check for is T2. You tell me what you're checking for. I'm going to pretend I don't know what T2 is, because I know everything in this one. This is the direction of motion. So I take T2 minus the force of gravity. So T2, oh sorry, I have to write down Newton's second law. Sorry, I'm skipping ahead, I don't want to do that. The sum of the forces is equal to F net, which equals MA. And the sum of the forces is T2 minus the force of gravity, and that equals MA. So T2 minus 58.8 is going to equal 6 times the acceleration of 5. That's 6 kilograms. Okay, I'm going to swing down here so I have more room to write it. So T2 is going to equal minus 58.8 is going to equal 30. That's what that is. 5 times 6 is 30. So T2 is equal to 88.8. I do my little squiggle around it because I've just checked it. 2 check marks. My happy face. And oh yeah. Oops. Ha. Yeah.